Hey guys, Mr. T here. It's another video on stem plots. This should help you with exercise 9E, in your 11 General Maths book. So this next section is about another way of displaying data, but stem plots in particular are good for displaying numerical data. And we've spoken about that. Numerical data is special because of the nature of the data. It's numbers, they all have a relation to each other. They have an increasing or a decreasing order. So stem plots are a good way of displaying numerical data when you want to see the shape of the distribution, or if you want to compare the distribution of two sets of data. A stem plot, also known as a stem and leaf plot, has two main sections. The leaf section has the last digit of each of the data values. This will become clearer when I actually do an example, but the leaf section has only the last digit of all of the data. So the last number in each of the numbers, it could be 135, so the leaf section would only contain the 5 out of that. And the second section is the stem section, which is made up of the leftover, the remaining digits, which is all except for the last digit of each data value. And the other thing is that the stem should have its digits written vertically, so the remaining digits of your data, except for the last, you're going to write them vertically, so straight up and down, and they go down in numerical order, so they'll get bigger as you go down the stem. You also need to divide the stem and leaf sections by a line, and you should always include a scale explaining how to read at least one of the data values. So give an example of how you read the data values. So to help you out with understanding, because these are words right now, and we all know that saying a picture's worth 1,000 words. When I do a stem plot, it should make sense what I mean by the leaf section having the last digits only, and the stem section being made up of the remaining digits. So in this example here, you're being asked to display the following sales data in a stem plot. So we've got a bunch of numbers. So your first step should always be to work out what the smallest number is and what the largest number is, so you know how far your stem needs to go. 82.75, so this is the smallest so far. 73 is the smallest so far. 71 is the smallest so far. So 71 is the smallest number. So the stem needs to contain all of the digits that aren't the last. So we've decided that 71 is the smallest, put a circle around that. Now we have to decide what's the largest digit, so we can finish off and decide how far the stem needs to go. So 106 is the largest so far, 112 largest, 115 is the largest, 118 is the largest. So, again, the stem is going to contain all the numbers except the last digit. So the last digit, I'll circle in white, is not going to be in the stem. The last digit's not going to be in the stem. So what are the leftover digits? 11 and 7. So that's the extent to which our stem needs to go. It has to go from 7. So this is the stem section. It has to go from 7 to 11, because those are the remainder of the digits, except the last are going from smallest to largest. So 7, 8, 9, 10, and 11. And what have I said as well? You need to divide the stem and the leaf sections by a line. Done. So this is the leaf section. And what did we say the leaf section is made of? The leaf section is made up of the last digits of each of the data values. So now we can go and fill this out with the leaves. So every one of these data values is going to be represented on this stem plot, with the stem representing the first part of it, and the leaves are all of the last digits here. So 82 would fit under stem 8, and it would be represented by a leaf that's 2. 75 would be stem 7, leaf 5. 106 would be stem 10, leaf 6. And so hopefully you're seeing how this is working. I'm slowly building it up, so we've done those. 89 was just drawn. 94 is going to be 94. 112 is going to be 112. 90 is going to be 90, and so on. So I'm just going to finish this off. I don't want to keep droning my voice at you, so I'm going to shut my mouth and just finish this off. But I'll probably breathe heavily into the mic. You can deal with that. 93, 85, 109, 73. No fast forward to this, unfortunately, so you're going to watch me actually do this. 11, 0, 71, 86, 77, 83, 96, 76, 106, 86, 91, 72, 80, 115, almost done, 75, 106, 74, 85, 97, 118, 78, 88, and 105. So that is a stem and leaf plot done. What are we missing? It always should have a scale representing how to read one example data value. So I'd write scale. And then the example I might use would be 1, 1, line 2. And then I would say that that equals 112. So that's representing this here, how to read it. It's 112. Okay, so that's actually an example of a unordered stem and leaf plot. You might be asked to do an ordered stem and leaf plot. Now what's that? That's just that stem and leaf plot, but with the leaves written in order, because the stem's already in order. So I'll quickly draw this as an ordered leaf plot and show you how fast it is that you can just order an existing unordered one. You're better off to do it unordered first and then reorder it because it's quick. So I've got the stems in place, so you look for the smallest number in the leaves and start with that. So 1, the next lowest number is 2, next is 3, next is 4, there's 2 5s, there's 6, 7, and 8. See, I've just reordered the numbers. There should be 1, 2, 3, 4, 5, 6, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so I've reordered it properly. The 8 stem has 2 zeros. There's no 1s. There's 2 2s. There's 2 3s. 3 3. There's no 4s. There's 2 5s. There's 2 6s. There's a 7. I think I lost count here. 1, 2, 1, 2, 1, 2, 2 6s, a 7, an 8, and a 9. Okay, that's done. Reorder this next one. 0, 1, 1, 3, 4, 6, 8, 7. So reordered that stem. Only a few more to go. 5, 6, 6, 6, 8, 9, and 0, 2, 5, 8. So all I've done is ordered, so you need the scale as well. Scale 1, 1, 0 equals 110. So all I've done to make it an ordered stem plot is get these numbers that represent all the data values in the leaves and put them into numerical order. That's an ordered stem plot. Okay, it's going to be a long video, I reckon, because I'm doing this all live. We're doing it live. Okay. Oh. Back-to-back stem plots. So we spoke about just before that stem plots are useful if you put two data sets on them for comparing the shape of data sets. Back-to-back stem plots are simply two stem plots for two separate data sets that you've drawn back-to-back on the same stem. So one on one left side, one on the right side. So this means you need to look at both sets of the data to decide what the lowest and highest data value, so you can actually have a long enough stem for it. Because if you just look at one set of data, you might have a nice stem for that, but it might not extend enough for the other set of data that you're going to draw on that same stem. So here's another example, and this should end the video here. Example, display the following basketball team score data before and after a special training program. So they got this score before being trained in this special program over a bunch of games, and then they got these scores after the program. And yeah, we're going to put them on a stem and leaf plot back to back and see if they've done any better or worse. So looking through both sets of data to see what the lowest number is. 85 is the lowest, 75 is the lowest, 74 is the lowest. So it looks like 74 is the lowest on this side. 77. So the lowest number in the whole thing is going to be 74. Now let's look for the highest number. 85, 87, 92, 95. 95 is the highest so far. 95 is the highest. So our stem needs to involve all of the numbers that aren't the last that go from 7 to 9. So your stem, and this is going to be back to back. Stem's going to go from 7 to 9, so 8, 9. Lines between the stem and the leaf section. So we're going to put before over here, after on this side. So 85, 87, 75, 79, 81, 92, 95, 86, 74, 81, 86, 90, 83, 87, 75, 94, 79, 83, 79, 87. I'm not going to bother ordering these because really we're just comparing the shape of the data and see which one has higher scores. So now the after program, the first score is 77, 84, 80, 87, 91, 86, 93, 88, 82, 79, 85, 92, 86, 93, 77, 82, 85, 78, 84, 76. So, what can we tell from this? You've got 5 numbers only on the 7 stem on the after, so there's more numbers in the 70 stem before training, so already it looks like there's less scores from 70 to 80, between 70 and 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 scores in the 80 to 90 range, whereas there's only 10 on this side. And then you have for an even number in the 90 bracket. So this isn't really definitive. It doesn't look like the closest thing to arguing that it's going to be that they got better in the after the program would be that there's less in the 70 to 80 bracket, but really there's nothing conclusive here. You'd have to run different statistics, maybe find the average score before and after to compare. But as you can see, the whole point of this is to show that let's say you had a more definitive result and you could definitely see what if the shape before was more, there was more of a peak in the low scores and then there was less down here. So you might have this shape like that. No, I might draw it. Let's say the bars looked more like this. Whereas after the bars might have looked more like this, that would be a more definitive result because there's more data after on the high end. But that hasn't happened here, but you can see that this example shows how back-to-back stem leaf plot would let you compare the shapes of two different data sets. So the only last thing that I've forgotten is to put a scale, because I've told you have to do that. So 91 is equal to 90, not 93, 91. Okay, so that should help you out with drawing stem and leaf plots and how you go about it. Hopefully that does help you out, and I will see you in the next video.